Hi there. Time for lesson 8, which is 1000 in binary. Yep. Okay. Lesson 8 is using unit analysis to convert measurements. Oh man, your teachers have drilled into your fat little heads how to go from like how many feet in a yard and how many inches in a feet and how many centimeters in a meter and all that kind of stuff. And this is where that stuff really matters. Really. In your science classes, you're going to be doing a lot of unit analysis as you move from one type of unit to another one. You've been probably raised on English measurements like inches and feet and yards and miles, but the world is really very metric. Okay, it's the metric system, people. I mean, it's the thing to do now. All right. Now, fortunately, all our road signs we've got things like miles per hour. Um, I measure things in feet per second. Look, for crying out loud, we need some meters per second here, and we need a way to figure out what's kind of about the same as something else. I had to convert in my head Fahrenheit and Celsius when I was in Great Britain. That was tough. So the more we get into the mode of meters, seconds, and metric system types of stuff, that's really going to carry over to your studies in science, where in physical science and in chemistry and in physics, you're not using feet and you're not using inches and you're not using hours. You're using those other SI system units. There you go. There's my diatribe for the day. There's my passionate, gut-wrenching this way the world is kind of thing. Let me start off with this. Let's just think about what this title here says. Unit analysis. Analysis is when you pull things apart into their pieces and look at them all and see what everything's made of. Okay? So we're going to take a unit and these combined units like meters per second or miles per hour. We want to just think about how that's phrased. You got something like miles is distance and hours is time. So distance over time type of measurement there, that would be speed or velocity. And this whole bit about units is not just describing what type of way they're measuring, though that is true. We also have today talking about unit that comes from the word one. Okay, unit has to do with oneness. Think about this: unicycle, unibrow. Okay, uni has to do with oneness. When we convert stuff from one type of measurement into another type of measurement, we are not changing that thing's value. We're just changing the length of the stick that we're measuring it with. Okay? Yardstick, not helpful, right? If I had a foot, a ruler, I would need 3 of those to make one of these, but I'd still be measuring the same distance. So really important that you get in your brain, I'm not changing anything about this. I'm changing the measuring stick that I'm using, but it's exactly the same distance or length or time or whatever that it was before. It's just measured in a different way. Now let's talk about that unit stuff. Okay, conversion factors use a thing called a unit ratio to go from one thing to another. That's where we talk about there's 3 feet in 1 yard type of business. Let's just start with that. If I had something that was like, I don't know, 5 feet, and the problem is asking me to put that into inches. Okay, and I know this is kind of like real basic, but let's start with this. I would need to start over here with 5 feet, and then I need to multiply it by a unit or conversion factor, but it needs to be equal to 1. So we would have to figure out the thing that we are going to. Units that we're going to, and the units that we're coming from. Okay? Here's where we're coming from. We're coming from feet, and then to, we're going to inches. So if you always set up your little ratio here, your little conversion factor like this, then that keeps everything in the right place, so things will cancel out, and you'll end up with the units that you need, and you'll multiply when you ought not to be dividing, or vice versa. This particular setup here, and I'll write that up here again, we're always going to have units to and units from. To, it's in the numerator, and then units that we're coming from are in the denominator. In this particular case, we're like, well, the units we're coming from would be feet, and the units that we're going to would be inches, and then you just have to think of what is the rule that unites those two, that shows how these two things are equal. We know that 1 foot is 12 inches. Now, if you took 12 inches and divided that by 1 foot, you get 1. Okay? 12 inches and 1 foot is the same thing. So you divide something by itself, or what it's equivalent to, you get 1. This basically is multiplying 5 feet by something that's equal to 1. And if you multiply something by 1, it stays the same. It stays what it was. It may look like a different form, but it's still the same thing. So we see here that if we do unit analysis, if we start looking at where our units are, feet will be divided by feet, so those units will cancel out, and the only unit left will be inches. And we're left with a multiplication problem. 5 times 12 divided by 1. 60 inches. Now put on your thinking cap. Think about how big an inch is, and you got 60 of those. Is that about 5 feet? Yeah, it should be. Your number should be a big number if we're going from a bigger unit to a smaller unit. We need more inches to make feet than going the other way around. Okay, that's a pretty simple problem, but they will get more complicated than that, especially if we have to take more than one step to get to the finish line. Let me change the things up on the board, and we'll talk about that, and then we'll go on to talk about changing dimensions. Okay, so hang on. They may have one that's going to include more than one step here to get to the finish line. We're going to have to use more than one unit conversion rate in order to get to our answer. So you can see I picking yards per hour. That sounds kind of weird. It's like, what am I, pushing the lawnmower? To inches per minute. I'm just going to roll my dice here to pick a number, put in there, and it'll be 5. Okay? I'm going to try to figure out what 5 yards an hour is in inches per minute. So again, most of these types of things end up being, what's your plan of attack going to be? And so we're going to need a little bit of information to figure out what our oneness things are, what our unit converters are. We have to go from yards to inches. We can't do that. Well, we could do that in one step, but we'll just do it in 2. So we're going to need to go I'll do it this way too. From yards to feet, and then we'll have to go from feet to inches. Okay, so doing that tells me I'm going to need a 2 on top and a from on the bottom. I'm going to need a feet to yards comparison, and that would be 3 feet is 1 yard. Okay, so I need one of those. And I'm going to go 2 inches. So I'm going to need one that's in inches that goes from feet. And that would be 12 inches is 1 foot. So I'm going to need that one. I'm going to need that one. But we also got here on the bottom, we're going from hours to minutes. Okay, so there's another one. We're going from hours to minutes. 2 goes on top, so we got to have minutes compared to hours, and 1 hour is 60 minutes. So we're going to need that one as well. And since all of these are just multiplying by 1. We can just string them in a row. It's all multiplication. We can start with our 5 yards every 1 hour. And we can just start with the ones that make the most sense. We're going from 2. So let's start with this one first. We can put this one in here. That's equal to 1. 3 feet, 1 yard. The yards will cancel out. I'm in feet per hours now. I need to get to the next one. I need to get to inches. So I'll use the next one. This is equal to 1. And now the feet cancel out, and I'm in inches per hour. Okay? And then we go to our last one. In order to go into minutes, we need our 60 minutes is 1 hour. Not the inches. The hours. Oops. Did that upside down, didn't I? 1 hour. Oh, because that's on the bottom. Okay. 60 minutes. That one's flip-flop because the hours were down here. So I would need to use the inverse of that to get where I'm going. Okay, the hours down here cancel out with the hours there, and I end up with inches per minute and a bunch of math. I have 5 times 3 times 12 over 60. Okay, and I know that 5 times 12 is 60, so those are going to cancel out. I'm going to have 3 inches per minute in order to go 5 yards per hour. Sorry I got like stuck on that one bit. When there's that denominator, I've got to make sure that now I got to go from and to. Okay. But you see how I kind of laid it all out first? It says, here's where I'm going. Here's the pieces that I need. And then I'm going to do this one step at a time. You could do 36 inches in a yard. That could be doing 2 things at once. And that's actually probably pretty smart. Now let's talk about when we've got to change dimensions. Okay? And we've got to go and change dimensions. That's next. Okay, time for 2-dimensional things. So we're working with all different kinds of things here. We can work with just straight up length or distance, which is only a 1-dimensional thing. It's a straight line. We already threw in a thing there, a rate like miles per hour, and how you've got 2 different things that you're switching. But then we have 2-dimensional, which would be area, and 3-dimensional when we have volume. Area would be something like saying square meters or meters squared, and volume would include something like cubing something. That number up there tells me how many dimensions I'm working with, and you see that that unit has to be converted more than once. I'll give you a quick thing here. If we had 12 square meters and we wanted to go to square centimeters, well, I know that 1 meter equals 100 centimeters, but it's not sufficient to change the units just once. I'm dealing with something that's been squared. I have to think of it in terms of every meter that I have is actually 100 centimeters. And then I have another dimension where that's been divided up into 100 as well. That gives me 100 times 100 squared units. Squared units in there. So if I'm doing that math there, 12 square meters would have to be converted twice. I can go that 1 meter is 100 centimeters, but that only cancels out 1 meter. I have to do it again. I have to do it like that. The other option is to do this and square it. That gives me square centimeters, and it means that the meters cancel out because they've been done twice. Volume, you're going to have to do it 3 times. Cubic meter, you're going to have to do that conversion 3 times, okay, in order to get the units that you're looking for in the end. So look at the number of dimensions and just realize that's your instructions for how many times that conversion is going to have to take place for you to go from a cubic measurement to another cubic measurement, unless you cook up a straight from here to there type of measurement on your own. Keep track of those things in your notebook, okay? Write the stuff down. That'll help you out.